Hi, all you cool cats and kittens. Let's take the antiderivative of this thing. So we have x to the 10. So we're going to add 1, so x to the 11, and then divide by the new power, which is 11, and then add our constant. This one is x to the negative fifth power, so I'm going to add 1, x to the negative 4, divide by the new power, which then turns into negative 1 over 4 x to the fourth plus c. This is x to the 3 fourths. I'm going to add 1, x to the 7 fourths over 7 4. So that turns into the fourth root of x to the 7th times 4 over 7 plus c. So the fundamental theorem of calculus, Sir Isaac Newton and Leibniz showed that the link between differential calculus and differential definite integrals or limits of the Aristotle we saw in section A. This link is called the fundamental theorem of calculus. The beauty of this theorem is that it enables us to evaluate the complicated summations we've already observed. So this is the integral symbol, and then a to b. So a is our lower bound and b is our upper bound of the function, and then dx. This allows us to find the exact area from a to b. Remember, like sometimes though, we have like perfect squares, and that's super easy to calculate. And then we have trapezoids, and then you have this different value. So to find the antiderivative, you're going to take. Remember how like if f of x is the antiderivative, like the integral, the antiderivative is capital F of x. So they plug in like you plug in your top value into here, and then your second value into here, and that finds you the area, and you subtract them. So essentially, you just take the antiderivative of this, you plug in your top value, and then your lower value. Let me give you an example. Right here. So use the fundamental theorem of calculus to find the area between the x-axis and y equals squared. So I'm going to draw the integral from 0 to 1 of x squared dx. So to find the antiderivative, I'm going to add 1 x cubed over 3, and then I draw a bar here from 0 to 1. And then now you plug in 1 and 0. 1 cubed over 3 minus 0 cubed over 3. For the most part, when you plug in 0, usually it goes to 0, but not always. So this is just 1/3. So the exact area under the curve from 0 to 1 is 1/3. For b, integral from 1 to 9 of the square root of x dx. The antiderivative is you have x to the 3 halves over 3 halves, which is equal to the square root of x cubed all over 2/3. And then plug in 1 and 9. I'm going to make this a little bit easier. I'm going to do the square root of x cubed over 3 from 1 to 9. So then what's the square root of, so square root of 9 cubed over 3 minus the square root of 1 cubed over 3. Square root of 9 is 3 cubed 27. 27 divided by 3 is 9. So 9 minus the square root of 1 is 1 cubed, which is 1/3. So this is equal to 8 2/3. And that is the area from 1 to 9. Okay, and that's how you find using the fundamental theorem of calculus. There's some rules that if you take the integral from a to a, you have like from a to a, there is no like space because it's infinitely thin, so the integral is 0. If you have a from a to b, you can flip it and do a on the bottom and b on the top, but it has to put a negative in front. If you have from a to b and from b to c, you can just add them from a to c. If you have a constant, you can take the constant out. Sorry. If you have a constant, you can take the constant out and then times the constant times your integral answer. And the integral of the constant is just the constant times c, b minus the constant times c. This one, if you have multiple terms like x squared plus x, you can do the integrals of them separately and then find the answer. You never really do that. So this is showing that if you take the integral from a to b plus b to c, you get the same thing. So you do f of b minus f of a plus f of c minus b. These cancel. So you have f of c minus f of a, which if you take the integral of just f from c to a, you end up getting this. We did those ones. Use the fundamental theorem of calculus to show. So this right here is capital F of A minus capital F of A, which equals 0. Check. Here. Let's do E. So we have from A, the integral is capital F of B minus capital F plus capital G of B minus capital F of A minus or plus capital G of A. And then over here, that's just capital F of B minus capital F of A plus capital G of B minus capital G of A. I'm going to rearrange it. This should be a plus, I'm sorry. Capital F of B minus plus capital G of B plus no, this was minus. I was right. Plus negative capital F of A minus capital G of A, which you can simplify to be capital F of B plus capital F of G, capital G of B minus capital F of A plus capital G of A. And get the same answer. It's the same match. The same. The diagram shows a part of the graph flaw. Write down the integral, which represents the area of the shaded region. So we know this is 0, and this other answer is going to be what? Set that equal to 0 and that equal to 0. You get negative 2x squared equals 0, and x minus 2 equals 0. So x equals 0 and x equals 2. So my integral is from 0 to 2 of negative 2x squared x minus 2 dx. That's part A. Part B is find the area of the shaded region. I'm going to distribute that. negative 2x cubed minus plus 4x squared dx. Take the antiderivative, you get x to the fourth over 4 plus x to the third over 3 from 0 to 2. Because you have bounded values here, you don't have to worry about the plus c. I'm going to plug in 2. And then subtract 0, which is super nice. When you plug in 0 into this, you're going to get a big fat 0. So it goes away and you end up with, I think that's going to turn into 8 over 3. So the area is equal to 8 over 3 units. So right here, I'm going to do the integral. So it's u squared over 2 minus u from 1 to negative 2. So I have 1 squared over 2 minus 1 minus negative 2 squared over 2 minus negative 2. That's 1 half minus 1, which is negative 1 half, minus, that's 4 over 2 plus 4, which I think is 6. So that, which is a negative 6.5. That just seems wrong. There we go. This is 2, and then this is 4 minus 4.5. This one is t to the negative. I don't know if we learned this one yet, but this is t to the negative 1. So then when you do that, you get t to the 0 over 0. But you can't have that because that's undefined, so that's not an option. What gives you the derivative of 1 over x? Nice job, it's ln. It's ln t from 3 over 2. So it's ln 3 minus ln 2, which equals ln of 3 over 2. So just remember that if f prime of x is equal to 1 over x, then antiderivative is equal to ln of x plus c. And the last one is 4x cubed minus 4x squared dx, 1 to 3. So this is x to the fourth minus x to the 3rd over 3 times 4 from 1 to 3. 3 to the 4th minus negative 4, 3 to the 3rd over 3 minus 1 to the 4th minus 1 to the... That's 4 times 1 to the 3rd over 3. And you end up getting... You get 45.33. So you remember your homework is 93, 4, and 5. I'll be on Monday if you have questions. I hope that helps.